Hello my dear students, today I will be discussing about computation of average rainfall over a basin. In order to compute the average rainfall over a basin or catchment area, the rainfall is measured at a number of rain gauge stations suitably located in the area. The network density of rain gauge depends upon the uses for which the rainfall data is intended. A network should be so planned as to have a representative picture of the areal distribution of rainfall. There should be no concentration of gauges in heavy rainfall areas at the expense of dry areas or vice versa. If a basin or catchment area contains more than one rain gauge station, the computation of average precipitation or rainfall may be done by the following methods, that is arithmetic average method or arithmetic mean method, Polygon method, isohydral method, and grid point method. Let us discuss about these methods one by one. So first one is the arithmetic mean method. If the rainfall is uniformly distributed on its areal pattern, the simplest method of estimating average rainfall is to compute the arithmetic average of the recorded rainfall values at various stations. Thus, if P1, P2, P3, etc. up to Pn are the precipitation or rainfall values measured at n gauge stations, then we have P average is equal to P1 plus P2 plus P3 plus P4 till Pn divided by n. That is nothing but 1 divided by n into summation of Pi. Okay. So second one is Polygon method. The arithmetic average method is most approximate method since rainfall varies in intensity and duration from place to place. Hence, rainfall recorded by each rain gauge station should be weighed according to the area it is assumed to represent. Polygon method is a more common method of weighing the rain gauge observations according to the area. Polygon method is also called weighed mean method and is more accurate than the arithmetic average method. The procedure of Polygon method is first you have to join the adjacent rain gauge stations A, B, C, D. These are the rain gauge stations A, B, C and D. Okay. First you have to join the rain gauge stations A, B, C, D by straight line. Okay. A to B, B to C, C to D, D to A. Construct the perpendicular bisectors of each of these lines. Then you have to draw the perpendicular bisectors of each line. So for this is the perpendicular bisector. For this is the perpendicular bisector. For this side, this is the perpendicular bisector. And for this is the perpendicular bisector. A Thiessen network is thus constructed. So there will be a Thiessen network. The polygon formed by the perpendicular bisectors around a station encloses an area which is everywhere closer to that station than to any other station. So after that, you have to find the area of each of these polygons shown hatched. After this, you have to find the area of this. This is the area of A and this is the B area of B station, and this is area of C station, and this is the area of D station. Multiply after that. Once if you get the area, then multiply the area of each Thiessen polygon by the rain gauge value of the enclosed station. So then find the total area, that is summation A of the basin. Then finally you have to calculate the average precipitation or rainfall from the equation, that is A1 P1 plus A2 P2 plus A3 P3 plus A4 P4 plus till AN Bn depending upon the rain gauge stations divided by A1 plus A2 plus A3 plus A4 like that till AN. So you can write like this also, summation of A into P divided by summation of A, means algebraic sum of all the area multiplied by the precipitation divided by the total area. Okay, so like this, in this way you can find what is the average rainfall by using the Thiessen polygon method. The next you can draw, I have drawn in a simple way. In this method, the rainfall recorded at each station is given a weightage on the basis of the area closest to that station. So draw the catchment area to the scale and mark the rain gauge stations on it. So these are the rain gauge stations 1, 2, 3, 4, 5, 6. Okay. Then join each station by straight line to create a triangulated network. So you have to join each line 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, then again 1 to 6, 2 to 6, 3 to 6, 4 to 6 and 5 to 6. After that, you have to draw perpendicular bisectors on each sides of the triangles. Extend the bisectors to meet the other bisectors and the catchment boundary. So after that, you have to draw the bisectors for the each triangles. So this is bisector, bisector, here bisector, and here is the bisector, bisectors. Okay. So then the polygons formed by the perpendicular bisectors are the influence areas of the each stations. Then you have to consider area for the each rain gauge station by using these polygons. Okay. Finally, you will get the average rainfall using the equation. This same thing what I have explained, same thing. Okay. So next is the isohydraulic method. Here, when the rainfall is controlled by topography or results from the intense convection, the isohydraulic method is the most elaborate and accurate method. Okay, so the basic assumption in the Thiessen polygon method is that a rain gauge station best represents the area which is close to it. However, this may not always be valid. So, especially when the rainfall controlled by the topography or results from the intense convection, the isohydraulic method is the most elaborate and accurate in such conditions. An isohydrate is a line on which a rainfall map of the basin joining the places of equal rainfall readings. An isohydraulic map showing contours of equal rainfall presents a more accurate picture of the rainfall distribution over the basin. Here, the procedure of the constructing the isohydraulic method is from the rainfall values recorded at various rain gauge stations, prepare the isohydraulic map for the storm causing the rainfall over the area. Next, you have to measure the areas enclosed between successive isoheights with the help of planimeter. Then multiply each of these areas by the average rainfall between the isoheights. The average rainfall is then computed from the expression Okay, this is the isohydraulic method. Okay, so here the average rainfall is then computed from the expression P average is equal to summation of A into P1 plus P2 divided by 2 into divided by summation of A. This is the formula to find the average rainfall using the isohydraulic method. Or you can write like this also, if P1, P2 and etc. up to Pn are the values of isoheights, and if A1, A2, An till An minus 1 are the inter-isohyght area respectively, then the mean precipitation over the catchment is given by like this. P bar or P average, that is equal to A1 into P1 plus P2 divided by 2 plus A2 into P2 plus P3 divided by 2 plus like that A3, suppose then P3 plus P4 divided by 2 like that, okay, into last point is plus A into n minus 1 into Pn minus 1 plus Pn divided by 2, the whole divided by A. Okay, you can write in short like this also, that is 1 by A into summation of AR into Pi plus 1 divided by 2. So this is the suppose contour. This is the iso height, means it is joining the points of equal rainfall. Iso height is a line on a rainfall map of basin joining the places of equal readings, rainfall readings. Suppose this is one contour showing the different iso heights. So this is almost same rainfall. So joining these two lines. Okay. Similarly for this 3 and this is 3.5 and this is 4 and this is 4.5 like this. These are the line joining the points of equal rainfalls. So let us solve some examples, numericals on this topic. So let us take this first problem. 4 rain gauge stations are located in a catchment area approximated by a circle of radius 100 km as shown in figure. Annual precipitation recorded by these stations in the year 2003 are A. At the rain gauge station A, the rainfall is 85 centimeter. At B, 130 centimeter. C, 105 centimeter. And D is 98 centimeter. Draw the Thiessen polygon and calculate the average annual precipitation on the catchment in 2003. So, it is asked to find the average precipitation using Thiessen polygon method. Okay, this is the rain gauge area. The rain gauge stations located in the catchment area. Okay, area is 100, radius of 100 kilometer. So now first step is what you have to, these are the rain gauge stations. First step, you have to draw the straight line connecting each rain gauge stations. Okay, so draw that. This is the rain gauge stations. These are the rain gauge stations A, B, C, D. First join each rain gauge stations A to B, B to C, C to D and D to A. Then again A to C and B to D. After that you have to draw the perpendicular bisectors for each areas. Okay, now for suppose this is the area. Okay, so the polygon is, this is the polygon area that is 1, 2, 4 into A. Okay, this is for rain gauge station A. Similarly, for rain gauge station B, this is the area that is 3, 2, 4. That is for D. Similarly, for C, that is 3, 2 and 5. Okay, for D, it is 5, 2, 1 or 1, 2, 5. This is the area for the rain gauge station A. Okay, for A, this is the area. For B, this is the area. For C, this is the area. For D, this is the area. How to calculate area? Now, radius is given, that is 100 kilometer. So, the area is pi r square. Okay. Here, there are 4 areas are there, rain gauge stations. So, you have to divide equally 1, 2, 3, 4. So, pi r square divided by 4. Okay, so you will get 7853.98 for rain gauge stations A, B, C and D. All areas are same. After that, you have to calculate average annual precipitation. What is the area to find annual precipitation? P1A1 plus P2A2 plus Pn divided by A1 plus A2 till An. So substitute P1 is 85. This one given value 85 and into area. Similarly, plus P2 is 130 into area plus 105 into area. So then total area. So then you will get P is equal to 104.5 centimeter.